Let's take a look at some of these tangent line questions using the power rule. And for this very first question, we need to find the equation of the tangent line given the following information. So anytime I see the equation of a tangent line problem, I go ahead and I just write out the equation of a line in point slope form. And then then I need to look at the information that's given to me. So f of -2 equals to 3. What that really means is that this is the point -2, 3. And then I'm also given that f prime of -2 equals to 2. So what that really means there is that the slope when x equals to -2 has a value of +2. So m equals to 2. And then from there, we're pretty much done, because when we're solving the tangent line questions, you just need to find the values for y1, m, and x1. So let's go ahead and finish off the problem now. So this will be now y minus 3 equals to the slope, and the slope is going to be +2. And this will be x. And since the x value is -2, this should be +2 to finish off. So x plus 2, and then I can close the bracket there. Okay, so that right there is the... Let's erase that and put an equal sign here. So that right there is the equation of the tangent line for this particular problem. Okay, let's keep on doing a few more of these tangent line questions so that we get the hang of, so that we are familiar with the procedure there. So once again, we have the equation of the tangent line. We need to find that for this quadratic at this particular point. So anytime you have to find the equation of the tangent line, let's start off with y minus y1 equals to m times x minus x1. Now, sometimes what you can do is that you can actually find the values of y1 and x1 right away, and that's given to us by this point over here. So what this really means is that this is your x1 value and this is your y1 value. So if we go ahead and substitute those values in, we have y plus 8 equals to m times x minus 4. Okay, so that part wasn't too bad. That's the pre-calc part. And then finally, we need to find the derivative value for this particular problem. And in order to find the derivative value, we need to take the derivative here. Okay, so let me kind of erase this here. So if I go ahead and take the derivative now, I can start off by writing y prime. And what's the derivative of x squared? Well, that's going to be 2x. And then what's the derivative of -6? That's going to be -6. Okay, so that's your derivative, and we want to find the derivative value when x equals to 4, right? So I'm going to change up my notation and write f prime of 4. And what that means is that anytime I see an x value, I just replace that with 4. So this will be 2 times 4 minus 6. And if we evaluate that, 2 times 4 is going to be 8 minus 6, and then I have a value of 2. So that means my slope value there is going to be 2. So my final answer is now y plus 8 equals to 2 bracket x minus 4. So that's the equation of the tangent line for that problem. Okay, let's go ahead and show a visual diagram of what we just found here. Okay, so this right here is what the tangent line will look like if you went and graphed this on Desmos, for example. So the equation of the blue line is the equation that we just found, which is y plus 8 equals to 2 bracket x minus 4. And clearly it's tangent right here at this point, so that point right there is 4 comma -8, and the parabola had the equation of y equals to x squared minus 6x. Alright, so that's exactly what we found there. So once again, going back to our answer here, y plus 8 equals to 2 bracket x minus 4. That's pretty much this right here, and clearly we are tangent at that particular point, which is, once again, this point is 4 comma -8. Alright, so there's a visual little sketch of what our answer will look like. Okay, let's do a few more of these, and we just kind of change up the problems here. So now we have another equation of the tangent line. So once again, let's write the equation of a line in point slope form. Okay, this time what we did last time was we found the values of y1 and x1. And this time we're just given the value of x1, which is 1, so we need to find the y value, right? So if I want to find the y value, I would compute f of 1. And what that really means is that all these x values will get replaced with 1. So this would be, I'll put a 1 there, and then plus 1 over 1. And we have to do a little bit of mental math here. So 1 to the power 4 is going to be 1, and 1 over 1 is 1. So 1 plus 1 is going to be 2. So that means f of 1 is equal to 2. And what that really means is a point. The point is 1, 2 there. Okay. So now that I know the point is 1, 2, we can go ahead and substitute that back into our equation of the tangent line. So this is y minus 2 equals to m bracket x minus 1. Okay. And then from there, our goal is now to find the derivative value. We need to find the value of m when x equals to 1. Okay, so let's go ahead and find the derivative value there. Okay, so let's go ahead and find the derivative of our problem here. And before we take the derivative, we can rewrite this as x to the power 4 plus, and this will be x to the power minus 1. So I need to find the derivative value when x equals to 1. So let's go ahead and take the derivative. I'll write this as y prime equals. Okay, so there's a 4 there, so that 4 can get soccer kicked to the front. So that's going to be 4x to the power of 3. And then this 1 can get soccer kicked to the front, so that's going to be negative 1. And then x to the power of negative 2. After that, we're going to rewrite this as 4x cubed minus 1. And then on the denominator, we'll have x to the power of 2. And this will be y prime. All right, so now we need to find the derivative value when x equals to 1. That's the key, right? So let's go ahead and find f prime of 1. So now I can write f prime of 1. And what that really means is that anytime you see an x, you just replace those x's with the value, the x value 1. And we can do some of this in our head, right? Because 1 to the power of 3 is still going to be 1, and 1 times 4 is going to be 4, minus, and then if I substitute a 1 in there, that's going to be 1 squared, which is 1, and 1 divided by 1 is 1, right? So 4 minus 1 is going to be 3. Okay, so there you go. There is my slope right there. So f prime of 1 is equal to 3. All right, so if I go back to my my equation of the tangent line here, the final answer will be y minus 2 equals to 3 bracket x minus 1. So that's the equation of the tangent line right there. Okay, now let's go ahead and take a look at the graph here. Okay, so the red graph is a little bit different. So the red graph, it's a weird function here. So I would say that the red graph right below here is y equals to x to the power 4 plus 1 over x. Okay, so anytime you see the red graph, that's the original function. And the equation of the tangent line, which is what we just found here, is going to be, what's it again, y minus 2. Okay, so it's going to be y minus 2 equals to 3 bracket x minus 1. And as you can see, there's a tangent line right there at the point 1, 2. All right, so if I graph the tangent line, which is highlighted in the green box there, it's tangent at that particular point, right? And that's exactly what we needed to find. Okay, let's do a few more of these tangent line questions with different functions, and then hopefully everyone will get used to this kind of a problem here. Okay, so now I need to find the equation of the tangent line when x equals to 2 for that particular function. Okay, so I can start by writing out the equation of the line in point slope form. And right away, let's go ahead and find y1 and x1. We know that x1 is going to be 2, so let's go ahead and find the y value. So that's the same thing as evaluating f of 2. And what that means is anytime you see an x, you just replace that with a 2. So this would be 3 bracket 2 squared minus 2 divided by 4. So this would be 3 times 4, which is 12. So 12 minus 2 divided by 4. 12 minus 2 is going to be 10, and that will be 10 divided by 4. And 10 divided by 4 is 5 over 2. Okay, so let's go ahead and plug in those values in. So this will now be y minus 5 over 2 equals to m times x minus 2. All right, so that's kind of step number 1. Find the values of x and y. X was given to us in the problem. And now we need to find the value of the slope, right? So m. Okay, so in order to do that, we need to take the derivative. Before we take the derivative, let's rewrite the original problem as, so I have a 3 and a 4, right? So I can write that as 3 over 4 x squared minus, and now I have a 2 divided by 4. So 2 divided by 4 is going to be 1/2, right? So we can rewrite that as 3/4 x squared minus 1/2. let's go ahead and take the derivative now. So y prime equals, all right, so this 2 gets soccer kicked to the front and it multiplies with a 3 over 4. So let's just write out the whole thing. So this will be 3 over 4 times 2, and then I have x to the power of just 1, and then the derivative of 1/2 is going to be 0, right? So if I go ahead and multiply 2 and 3 and divide that by 4, I guess we get 6 over 4, which is 3 over 2, so that'll be 3 over 2 x. Okay, now remember, we want to find the derivative value when x equals to 2, right? When x equals to 2. So what we really need to do now is I need to find f prime of 2, which equals to 3 over 2, and then there's an x value here, right? So anytime you see an x, this x gets replaced with that 2, right? So if I erase all this now, I can just times this by 2. And you'll notice that this and this will cancel, just giving you a 3. Okay, so final answer here, I'll write this in green. The final answer is y minus 5 over 2 equals to 3, which is the slope, and then x minus 2. All right, so there's our final answer right there once we've plugged in all the right numbers there. Okay, and once again, we'll have a visual graph of this particular solution here. So the parabola has the equation y equals to 3x squared divided by 2 over 4. That's the equation of the parabola. And the equation of the linear line is what we just found here, which is y minus 5 over 2 equals to 3 bracket x minus 2. And we're tangent at this particular point, which is actually, this point is actually 2 comma 5 over 2. And 5 over 2 is the same thing as 2.5, right? So that is a visual sketch of our solution. All right, let's go on and take care of a few more other interesting functions here. Okay, so this one's a really good function here because it's not like a linear or a simple quadratic or a polynomial here. So let's go ahead and find the equation of this tangent line. And let's start off by writing the equation of the line in point slope form. And our goal is to find y1 and x1. And we know x1 is equal to 8. So let's go ahead and find f of 8. And what that means is every single x value gets replaced with 8 there. So I have the cube root. Now, it's probably better. I know you should write it like this. But a better way of solving this problem is that we take the cube root of 8. And then we take all of that and then we can raise it to the power of 2. All right, and the reason I do that is because we know what the cube root of 8 is. The cube root of 8 is going to be 2, and then raise to the power of 2, and that's going to be 4, right? So what that really means is that the x value is 8 and the y value is 4. Okay, so if I go back and update our formula, I have y minus 4 equals to m bracket x minus 8. Okay, good. So a little bit of a slight challenge there in terms of getting the y value. Okay, and then from here on, let's see what else we can do. We need to find the derivative value, right? We need to find m. So in order to find the slope, let's rewrite our power as f of x equals to x to the power of 2 over 3. Okay, so it's very important that we're able to write that as a power there. So this index is on the bottom there, right? So now let's take the derivative using the power rule. So f prime of x equals 2. Well, the 2/3 gets soccer kicked to the front. The x remains, and then we subtract the power by 1, which is the same thing as minusing 3 over 3. So that's going to be negative 1/3. Okay, and our goal is now to find f prime of 8. But we should definitely simplify this as much as we can. So I'll start off by writing this as 2 over 3. Alright, so this 2 is that 2, and clearly this 3 is that 3. And now the challenge is, what do we do with this part here, that negative exponent, right? That's really the same thing as the cube root of x. Alright, so that's what happens when we simplify this back into a radical. And what's really nice is that we know that all the x values need to be replaced with 8, right? So if I replace this with 8, I get cube root of 8. And that's nice because we know what the cube root of 8 is, right? The cube root of 8 is simply going to be 2. And now I know that this and this cancel off, and that gives me 1 over 3. All right, so the derivative value when x equals to 8 is 1 over 3. All right, so final answer is y minus 4 equals to 1 over 3 bracket x minus 8. Okay, that's great. Let's see if we have another visual here to help students here, and we do. Okay, so we do have a cusp here, right? The original function has a cusp, so the original function was f of x equals to the cube root of x squared, and the tangent line that we just found, which is in red here, I'll write at the top here, y minus 4 equals to 1 over 3 bracket x minus 8, and clearly there's an intersection point right here, and that tangent point is 8 comma 4. Okay, so there it is. There's another tangent line question where the linear line just touches the original function at a particular point, and that particular point is 8 comma 4. Okay, one last question to finish off this homework video guide here. Another tangent line question, but the function is a little bit different. So once again, for the millionth time, it seems like I keep on writing out this line in point slope form. And let's go ahead and find x1 and y1. We know x is equal to 4, so let's go ahead and find the y value. So this will be g of 4, and that means that every single x value gets replaced with 4, right? So this is 8 divided by 4 to the power 2 plus 2 over the square root of 4. All right, so a little bit of work here. Let's see what we can do here. The numerator is going to be 8. The denominator is going to be 16 plus 2 over 2. Okay, so this will be equal to 1/2 plus 1. And this is the same thing as a 1.5, right? So a half plus 1, 50 cents plus a dollar is $1.50, and that's the same thing as 3 over 2. Okay, and if I had to go back and update my formula here, now I have y minus 3 over 2 equals to m bracket x minus 4. Okay, so that is my updated equation of the tangent line there. And just like all the previous problems, now we need to find the derivative value, right? So our goal now is to find the value of m. Okay, so let's see if we can do that here. So in order to find the value of m, we should rewrite the problem into powers. So this will be 8 times x to the power negative 2 plus 2 times, and this will be x to the power of negative 1/2. Okay, so there you go. We've written everything in terms of a power, and now we can go ahead and find the derivative. So this will be g prime of x. All right, so using the power rule, we'll take this negative 2, and that gets soccer kicked to the front. So 8 times negative 2 is going to be negative 16. So negative 16 x to the minus 3 plus, actually not plus, but I have negative 1/2, and negative 1/2 times 2 is going to be negative 1. And that'll be x to the power of negative 3 over 2. Okay, this is looking okay. So now when you find, the goal is to find g prime of 4. Okay, but what I'll do first is I'll rewrite this back into positive powers. So this is 16 over x cubed, negative 16 over x cubed, minus 1 over the square root of x cubed. Okay, so now we have to figure out this particular problem if we can. So we've got to find g prime of 4. So all the x's are being replaced with the 4, right? So let's go ahead and write out our next step here. So this is negative 16 all over 4 to the power of 3 minus 1 over. Now for this part here, I will write it like this, the square root of 4. And since you have a 3 right here, you can change, basically you can just put all this in a bracket and raise to the power of 3, and that might be a little bit easier if you had to simplify this. So this is negative 16 over 64 minus 1 over, well, the square root of 4, the square root of 4 is 2, and 2 to the power of 3 is going to be 8, so 1 over 8 there. And let's see if we can get ourselves a common denominator here. So maybe negative 16 over 64 minus 8 over 64. And then if we go ahead and I'm just going to use a calculator here and just find the numbers here. This is negative 24 over 64. And then if I convert that to a fraction, I would get 3 over 8, negative 3 over 8. Okay, so that was a very long question. So the final answer should be y minus 3 over 2 equals to negative 3 over 8 bracket x minus 4. So a little bit of some mental math to kind of finish off that last question there. Okay, and here is a visual diagram of what we've just found of our answer here. So this linear line is y minus 3 over 2 equals to negative 3 over 8 bracket x minus 4. And the original problem was g of x equals to 8 over x squared plus 2 over root x. And I guess the intersection point right there, there it is. That point right there is really 4 comma 3 over 2. Okay, so that concludes this homework video guide on tangent lines using the power rule.